Hello everyone, my name is Rey Garza, and I'm going to be presenting some research from Annalise Cavalcanti and colleagues, and their research is titled Early Exposure to Environment Sounds and the Development of Cortical Auditory Evoked Potentials of Preterm Infants During Their First 3 Months of Life. Now hopefully that title doesn't bore you already or make you confused. We're going to go through it together. This is pretty interesting research and pretty relevant. So first, with our background information to get everyone up to speed, let's first define preterm birth, because that's mainly what we're looking at. This is when babies are delivered before 37 weeks of age. It's important to note that the primary auditory cortex in the brain of these babies is basically matured by 28 weeks of age. They can already start picking up low frequency sounds, so that part of the brain is structurally mature. However, it's still very tiny. It still has to grow, so it has to grow in size and volume. Their researchers were specifically looking at cortical auditory evoked potentials, which I'm going to be abbreviating to CAEP. Specifically, though, they're looking at the P1 component, which according to this research is about the golden standard when it comes to looking at maturity level in these primary auditory cortices. And specifically, we're looking at late preterm babies, 32 to less than 37 weeks of age. And this is, like I said, kind of relevant because this accounts for about 85% of all births that have been happening to date. Okay, now let's get into our methods really quickly so that way we can get over to our results. So for our methods, researchers are using their subjects as they were 23 infants and their gestational age was 31.28 weeks of age up to 41.42 weeks of age. And in the next slide we'll see that those are divided into late preterm and then term, so meaning like born at an appropriate time. Researchers divided the infants into two groups and evaluated them at 1 or 3 months of age. They delivered stimuli through the right ear, and they were using sounds such as ah and da sounds. Researchers monitored the CAEP recordings from the right mastoid, and then grounded an electrode on the left mastoid. So a mastoid is a little bone on the inner ear that we all have, and it's pretty responsible for detecting different sorts of audio signals. So for methods continued, researchers started measuring 100 milliseconds pre-stimulus, and they went all the way up to 500 milliseconds post-stimulus. The rate at the stimuli that they used it at every 1.9 seconds, and they did up to 150 individual sounds per infant. And with this, they're measuring the latency, so how long it takes the P1 component to detect any signal, any sounds around them. Alright, now we can get into our results. With our A chart here on the left, the solid line represents the median for children at 1 month, and the dotted line represents the median for children at 3 months. A circle is representative of preterm babies, and a square is representative of term babies, so babies born at an appropriate time. We can see that as far as latency is concerned, the term babies are picking up audio signals pretty significantly quicker than their preterm counterparts. Most of the circles we can see on the top line, and those are all around the 300 millisecond range, as compared to the term babies, which are from anywhere from the 150 millisecond range up to like the 250 millisecond range. But now where this gets really interesting is in this chart B that we're going to look at now. On this left side we have 1 month, and we're showing preterm and term. So at 1 month preterms, this line right here, all these 4 lines represent the medians. So for preterms, they're showing a median of about 300 millisecond latency when they're given audio signals. And the term babies are given just about the same. There's not much difference at all. We do have our one outlier, but he doesn't really change the mean too much. Most of these guys are up here around the 300 millisecond range, and this is at 1 month. However, when we go to the 3-month range, this is when it kind of flips basically. Data is showing that the preterm babies are detecting audio signals before their term counterparts. They're sitting right under the 200 millisecond range, and the term babies are sitting above 200, maybe around like 250 milliseconds. That's their median. And in this next slide, we'll get into why this is really, really important. So continued results, and what does this mean? So P1 latency component, this means that it's not correlated with age at both the 1 and 3 months of age. For preterms, auditory cortical circuits are maturing quicker. Also in preterms, auditory input processing is more efficient. Preterm babies' brains are very adaptable, it's showing that they're adapting quicker than their term counterparts. Researchers are believing that developmentally, this area of the brain is at less risk for damage than other parts of the brain. So what this kind of means is that as compared to other sensory systems like the eyes or the nose, anything with touch or smell, that those may take longer to develop. However, when it comes to audio with our ears, it's almost as if the preterm babies are getting sort of a head start when it comes to learning about the different types of sounds around them, different audio levels, direction, those sorts of things. They're picking that stuff up much quicker, much more efficiently than their term babies. This is just showing how adaptable the brain is. However, this does not mean that preterm birth is the safest or healthiest thing. Just because the ears and the audio parts of the brain are developing rather well despite being preterm, other areas of the brain are probably not going to see the same benefits. But for this particular research, these preterm babies are showing better. Their auditory cortices are just working better. They're working faster than their term counterparts, and this is, like I said, basically because they're out into the world sooner and they get a quote-unquote head start. So just real quickly to note, there are some limitations that the authors noted. They did say a small sample size was one of their limitations, and that's pretty true. Sample size of 23 is not very, it's hard to really get behind that. However, this research is very important. It's something that we should be learning about and knowing, so a bigger sample size would be beneficial. They also noted that they needed to use a cross-sectional experimental design instead of a longitudinal experimental design. And they only considered the role of extrinsic variables, so environmental exposures, when it is also known that cortical maturity is influenced by intrinsic variables as well. So if there's anyone listening to this, you could definitely work out some of these limitations and just add on to the knowledge when it comes to preterm babies. So lastly, this is my works cited for this presentation. I hope you all learned something today and enjoyed it, and I hope you all have a great rest of your day. Thank you.